Okay, hello everybody. Hello everybody here, and also hello to everybody who's watching online. Welcome to this, our first Edsign lecture for, well, quite a while now.
Recording.
My name is Gabrielle Hodge. I'm deaf. I work here at the University of Edinburgh as a sign language linguist. The Edsign Lecture Series, if you don't know, has been set up by 4 universities working in conjunction with one another. There's Edinburgh University, where we are right now, Heriot Watt University. Something dropped? Something exploded? Something exploded? I don't think it was real. Let's not panic too much. But I did feel the earth move. But it is, I don't know whether it was for, was that for the University of Edinburgh or Heriot Watt? We got that little explosive round of applause. Okay. The other 2 universities in Edinburgh that are working in conjunction are Queen Margaret University and finally Napier University. All 4 based in Edinburgh, working with an MOU. I'm very happy to say we've got 2 very special, smart, deaf women with us here this evening, both experts in STEM research, science research. They've come together to collaborate on a topic that I'll let them explain. There is Audrey Cameron, our own Audrey Cameron from the University of Edinburgh. So she's one of our presenters, and we have a visitor all the way from the United States of America. Her name is Caroline Solomon. That's her name, Carrie, I believe, in sign language. So I'd like to welcome them. Audrey is going to be signing in BSL. So if you're watching online, you're going to see her standing here. She's going to use BSL. Carrie is going to be signing in American Sign Language, but we have an interpreter here, Robert Adam. He will be interpreting into BSL for us this evening. Thank you, and I hope you enjoy the evening. Okay, I think we're at the point where we're ready to introduce ourselves, aren't we now? Can you see us both on the screen okay? I'm just going to check with our technical people. Everything seems okay. It's a bit awkward, obviously, with all these different screens. And hello there, online people. I'm Audrey. That's Carrie.
Hello, everybody. I'm Caroline Solomon, Carrie Solomon. I'm a professor of biology.
I'm a chemist, so as you can see from the picture above, I love to do explosive experiments like the one we're running just off here. My research has predominantly been, well, my training is in chemistry, drug development, and also improving paint technology for painting and decorating. Those were my areas of chemical work and research. Caroline? Sorry, I should just say that I work here at Edinburgh University, research in science, education, and sign language.
Okay, am I ready to start? Who's going to be controlling the slides for us? Okay, we're ready to move on to the next one. Thank you.
Can we actually just go back to the first slide for just a moment, please? Thank you. Just go back a couple. It's a bit strange when you don't control it. So go back to the very first slide, the title slide, please. Okay. So our presentation is really linked to where we are. The year 2023, the global year of STEM, and what we are doing in the area of sign language lexicons. So first of all, we should clarify when we talk about STEM, we're talking about science, technology, engineering, and mathematics. That's what that acronym means. We used to fingerspell STEM, but we've decided that we'd like a sign now. This is our sign for STEM, just to incorporate all the different sciences that fall under the umbrella of the term STEM. So that's how we brought them together in that sign. So there's a focus on the signs themselves, how different projects all over the world develop different sign terminology in the area of STEM. And there's a lot of effort. There's a lot of projects going on in the world, a lot of promotion in deaf communities the world over in the area of STEM lexicon development. So it's a very exciting time to be talking about these lexicons or dictionaries. So that's what we're talking about. We're talking about word or sign lists, okay? There are a number of different people whose names are on this slide, and they are from America, the UK, Canada, as you can see, and I represent the BSL team, which is a fast-growing team. We've got Gary Quinn also here this evening, and Sujit Sahasrabudhe is here with us this evening. I think that's, yeah, you're in the team now, aren't you, Sujit? Good. So, yes, can we please move on to the next slide? Thank you. And the one after, great. Okay, so here is an example of some of the glossary or the vocabulary lists that we have with our project here. So we're going to start off with what we're doing here in the UK. Obviously, we are producing signs in British Sign Language. This slide shows you how we've grouped together the signs into categories. Plus, of course, there's an A to Z facility for being able to search up terms. So people can use topic areas or general sign word lists in order to search for terms. And there are 36 people, deaf and deafblind scientists working on this team. Teachers, sign linguists, and scientists. Now, we don't all come together at the same time. We come together in smaller groups depending on the subject area that we happen to be working on at that particular time. We work obviously with teachers because we're focusing on developing signs for school children to use in their education. And this project's been running for 16 years now. Rachel O'Neill, who's also here from the University of Edinburgh, she was in the inception group of this project. And let's have a look at an example of one of the signs, one of the terminologies that we have within our SSC BSL glossary. So here is an example. You could click on a term like interdependence to see what the sign looks like. So that's the term that's been searched up by somebody. We might have to, we're trying to show you a video. We might have to, it's Halloween, eh? The ghosts have taken it. Interdependence, this is what the sign looks like. I'm showing you it now in lieu of getting the video working. So, as the sign depicts, it's entities depending on one another, such as bees and flowers having an interdependent relationship. The flower depends on the bee as much as the bee depends on the flower. Hopefully the video will work. Can we see the example? There we go, interdependence, as it appears on our BSL glossary. So we have the sign, but I mean, the signs aren't clear in and of themselves. So if you have a look at the next slide, you'll see the other major glossary, where we have these definitions in BSL as well as English. You can see that the English paragraph is up there, but we have a BSL video. So for all of the terms in our glossary, there are not only the translations, these are not translated from English, these are originated in BSL, and the videos originated in BSL. So we don't have time to look at that, but of course, when you do have a look at the glossary in your own time, you can explore that. And it's something of great interest to us in terms of who comes up with these signs, the people involved in the team, and we'll talk to that later on in the presentation. Is it over to you yet, Carrie? I think it might be. We have the next slide, sorry. We have the next slide. Okay, it's over to Carrie.
Okay, so first of all, I can sign in Auslan, but I'm quite tired tonight. I've just arrived this morning, so I will be signing in ASL just to make everybody aware. So one thing that I wanted to share this is a culmination of STEM, sign language research from all over the world. There's people working individually on these projects in different countries, but they haven't yet come together to have this discussion. So we're showing the different areas in the world where this research is active. These research projects are currently ongoing. So there are more examples, 2 more that are new. Oh, next slide, please. So in India as well, there's an example that I haven't actually added in the video just yet. Okay, next slide, please. We have Brazil as well. So here's one example in Brazil of an ongoing project, and we do have more examples as this grows globally. These projects are taking place throughout the world, and the aim for this year is something that I'd like to share with you as well. So in this slide, we're thinking about why do we actually need these STEM sign language lexicons? So the first point is regarding access to education. Access to research, secondly. Access to employment. And access to public health information. As well as access to climate change and disaster risk reduction, and also emergency planning. These are all crucial aspects. So as you can see here, this has been a wonderful year so far regards to STEM sign language lexicons. There's a German physicist so it's Inigo Barth from Signment in Germany. And we want to get together to talk about these signs. So we have different people who are involved, different universities, different institutions and ongoing projects. So there's been a lot of events so far this year, as we can see on this timeline here. So it's been quite an international year this year for STEM sign language. So this began in March 2023. And this was a workshop that took place at Gallaudet University. So the people included in that were people who were leading this work, and this was over 2 days. It took place over 2 days, and it was a very rich discussion. There were lots of questions, lots of different areas discussed, and several important points around the ethics surrounding this. And also what happens in K-12 education. And the third thing discussed was how to make sure that this is sustainable throughout the educational journey. So if we just go back to the previous slide. So after this working group or workshop, we collated the various information, put this together, and we created a draft, a white paper with all of these ideas. And this is going to be used for further discussions. So that was from March 2023. And then we went to Korea. I did a presentation there at the WFD conference to find out a little bit more about what was going on in India and Japan, Brazil, and these other ongoing projects worldwide. And then in August, there was the European Deaf STEM Camp. There were 30 people who attended this. Had, again, very interesting discussions. Audrey was there along with 2 young people from Germany. And they did a pre-symposium. And then there was also an event in Austria. So this was about where we're going to go next in this area. And then here we are today at the Edsign event in Edinburgh. And next month, we will be having another event, which is a symposium for STEM educators and interpreters. And this hasn't actually happened. Interpreters and educators haven't actually come together yet. And then again in March 2024, we'll be following this up with everybody coming together for this summit at Gallaudet University. Interpreters, sign linguists, educators will be invited to come and gather at Gallaudet University. People are starting to register for that just now. And the deadline is the 1st of December, so there's a lot of engagement around that, and we're very excited for people to come and join that discussion. Next slide, please. So this was a photo of back in March. You can see at that workshop there was a lot of discussion. Gary is actually there in the picture, if you can spot him. Are you hiding, Gary? Okay, spotted Gary in the picture there over on the left. Next one, please. This was our presentation in Korea. So I'm presenting in this photo. I'm with Chris Kurtz, Kim Kurtz. And you can see one of my colleagues there in blue. And Raja as well is in that picture in the light blue. This was from the camp, which was a very successful event. 30 people came together to enjoy this. Ready for the next slide? And then recently this took place in Vienna. This was the workshop for deaf academics who came together. It was a really good coming together of people within the field. So some people were present at the previous events in March, and we had some new faces there as well. And this is going to be coming soon for educators, our teachers and interpreters. And then in March 2024, this will take place. This will be the culmination of all the events throughout the year. So now I just want to talk a little bit about the working groups that we have in place. We have 3 to add more information as we go along, and also to culminate the discussions that we've had so far. We have different ideas and different considerations. We have 6 main areas of consideration. First of all, we have the ethical considerations. Lexicon development, what takes place in the classroom, multilingual approach, gaps in sustainability, and lastly, future technology, considering AI and advances in the future. So today we're going to be talking about 3 of these, the top 3, ethical considerations, lexicon development, and what takes place in the classroom. So there are questions that have arisen from the discussions in the working groups. So firstly, ethical considerations. Who develops the science? And who makes the decisions? Who is qualified or has the right to do this development work? and who's responsible for deciding on the right signs. Moving on to the second component, which is lexicon development. What is validation? That's our first question there. We also consider the standardization okay in some cases, as well as the differences in corpus, lexicon, and dictionary. What is the difference between those three resources? And the last area for consideration is the classroom, assessing whether students are learning from these signs. Are there any studies based on that? And iconicity, is this such an important factor? Okay, so first of all, we'll discuss the ethics. So when we look across the different groups, and we take a step back and examine this, we can see that first of all, these were developed by hearing educators of the deaf, or hearing linguists. Some interpreters have also developed lexicons, as well as SMEs, which are the subject matter experts. And that's being led by hearing people. But we also have deaf SMEs as well. So now there's also deaf-led projects that are starting to develop. So it's important to consider in some countries there are deaf educators, but deaf education isn't very good in some countries. Considering whether deaf or hearing people are leading the projects, some countries are still developing in terms of deaf education. And the community of deaf educators is growing and becoming better. And some projects have been hearing-led, but involving deaf SMEs. And then we have seen development in later stages of deaf-led teams. So we can see the transition from hearing-led to deaf-led models. And one thing that's particularly interesting is that if there's too many deaf SMEs, one study has found this can actually prolong the discussions and lead to prolonged periods of time discussing and less ability to decide on the lexicon. Next slide, please. So America has currently many different resources in place. So as a biologist myself, I find this particularly interesting, how these have changed over time. And then RID in 1970. This process began. We can trace this over time of the development of the different projects. The first US STEM project we can see was a dictionary project. And then there was the STEM Sign Video project. And then ASL Core. And we can see how this has fed down to the emergence of more projects. And they've all influenced each other as things have developed and built over time. And it's really interesting to see. We can also see in other countries, such as France. France also has a very similar model of development and the same evolution taking place over time. Oh, just sorting a technology issue there. Okay, next slide, please. So another thing that emerged from our discussions was this question. Who really qualifies as an SME, a subject matter expert? Who is qualified to do that? Is it somebody who is a native signer, who has worked in the STEM field, perhaps an educator, an interpreter, a professional? could it be a deaf professional who works in STEM? But we have to define working in STEM. What does this refer to? And in fact, could this be a deaf person who acquired sign language later on in life? And potentially a deaf person such as myself. I'm a biologist, so I could be, do I only work in biology, or am I qualified to actually help with the creative process in different areas of STEM and other disciplines? Should you just be focusing on your own discipline, or could you contribute to this more widely? So these are questions that are ongoing and haven't yet been resolved. Okay, next slide, please. So now we're moving on to consider the validation and standardization. Oh, somebody's commenting online that it's a bit blurry. The camera's a little bit blurry. So this is an interesting point here. Last March, we had a team of linguists, also scientists, present to discuss this. And we found that the linguists would say, from their perspective, that if a sign enters common use, whether or not it's conceptually correct, then it is in fact valid. However, scientists have a different perspective. We discuss things more intensely, and then we use our focus groups to agree on the signs that are valid. We also consult with other stakeholders. So we can't say whose view is right or wrong on this. Okay, next slide, please. So in terms of standardization, these were the points that came up throughout the workshops. Should we have one standardized lexicon within schools to avoid children getting confused regarding different signs? Or is it good to expose children to different signs, different variants? So for example, within the English language, you could say happy or joy, or joyful or glad. There's lots of different terms. And the same could be considered in sign language, whether this would benefit children or whether we should have a standardized approach. Within hearing people, when they work in science or STEM fields, there's lingua franca within English, and commonly used terms and symbols that are consistent. So the periodic table, for example, of elements, that's consistent and standardized. And similarly, metrics or units of measurement, should they be standardized? And these symbols that you can see here, micrometer, alpha, beta, these could potentially be standardized. So we have 5 deaf physicists, for example, one from Germany, one from France, one from America. Could they all come together to work together to share signs from their different countries, maybe share the same variants? That's a potential question that we hope to answer. Next slide. This is another thing that came up in discussion. Considering the different resources, corpus, lexicon, or dictionary, we have these different systems, and also a glossary could be added to that as well. So why do we have these different resources? Different words for the same thing, essentially. So a corpus is a representative sample. So you can look through different annotations and different videos which have been annotated within the corpus. A lexicon is a word bank that is organized around certain principles, including both the word and the sign, and it's grouped by different topics or by alphabetical order. Most lexicons are actually of this type. So there's the word or the term and then followed by an explanation. More recently, we have seen some educational videos to explain the concept and definitions of different terms. So that's something that's emerging more recently. But we don't have a term for that new resource as of yet. Okay, next slide, please. So this is a hot topic at the moment, and that's conceptually correct science. So a linguist once asked a group of deaf scientists, why are you so obsessed with creating conceptually correct signs? Why can't there just be a sign that's accepted and that's it? But really, we as scientists want to make sure that we are teaching conceptually correct signs. The sign has to directly relate to the concept itself. So, to provide an example of this, from socio-cultural aspect, for example, if we consider Inuits, they may have many different terms to define different kinds of snow. This is a socio-cultural example, and we need to take this into account. We also have the phonological or morphological aspect. So there are many of these rules that deaf sign language linguists maybe aren't aware of or aren't trained in. And also we have to consider iconicity. Iconicity is really an interesting area in of itself. So now I want you to see for yourselves whether you think that the following signs are conceptually correct or not. So if we can click on the first link, please, and we'll have a look at this video.
While we're waiting, I thought I may as well fill in this space. Oh no, here we go. So do we think that that sign matches the concept? I hope that you know what an atom is. It's kind of hard to explain it without using my own British signs. We're talking about an American sign. It's a bit weird.
So we have a few different signs. So if we click on the example for protein, you can see one here. Different signs for protein as well. We click on the other link on the right. We have another video on the right there. Under other submissions. So we can see that lots of people have submitted their own versions. We have one more. So I'll ask you just now whether you think these are conceptually accurate. We have one more example in BSL. Can we show the BSL example?
it is very, very hard to pick what signs to use to match or map onto concepts. And there was one that we found that was perfect. It was from the BSL project, and it was atom. Yeah, when we think of atoms. But then, of course, we look at the sign from ASL, and there was a good debate as to which was the better and which is the more representative of these signs, because both of them describe exactly what's going on with an atom. But it's very hard to encapsulate all the possible manifestations of atoms. So then when we think about a term like protein, you can see that there were 3 different signs offered up. Which of those really matches the concept best? Is it an edible protein, the type that you find in chicken? Or is it a microscopic protein that you find in nature? It's very, very hard in these teams, obviously, as a result, to pick what signs match or map the best. So can we go to the next slide, please? All right. So apparently we need to increase the volume for everybody online doing so. So I'm focused on this last of the 3 strands here, what's going on in the classroom, and that very much is from the research that I've been involved in. What did children talk about? How did they talk in the classroom or sign in the classroom about science concepts? All the way from the ages 4 right through to 17. So we have been observing a lot of what's been going on in educational settings, and we're left with these 2 questions. Do we have any studies that actually assess what students are learning by using these signs? And secondly, how important is iconicity? So can we move on to the next slide, please? Okay, so as you can see, there have been research studies to try and find out the efficacy of using sign language, but clearly not enough. We need a lot more research in this area. We've had research into how STEM materials are accessible in sign language. And that's really, obviously, the main focus of this. We have other studies which test the effectiveness of lexicons in the classroom as to whether they are too complicated for children at early stages. So we've been assessing their usage, and Gary and I have been to a number of schools asking them what they think of certain signs, testing their comprehension and their preference for different signs. So it is incredibly important that we have more robust research looking at what is going on in the classrooms, how the teachers are using those signs, how the signs are being incorporated into the classroom. We've been asking children the meaning of science concepts as a way of testing their comprehension. And we've been using group interviews, but we have really only scratched the surface, and there's a great deal more research to be done in this area. Next slide, thanks. So here's a little bit about the research that I've been doing lately, the Signing to Know study. So as I said, we've been filming in different classrooms in a number of different schools. Obviously, we've been doing observations of science lessons in a range of classes in primary and high school, asking them what all these terms mean to them. We're very, very interested in what the dialogue in the classrooms and how the STEM signs are used. So how they're used in the real world, away from all these wonderful projects that we're running. How the children use the signs. Do they use the signs from the glossary? Or are they creating and using their own signs? So we really wanted to observe and find out what was going on in the real world. And we had very interesting observations. A lot of good work was going on at the schools. But electricity as a topic was particularly interesting to us. I don't know if you in the audience know the difference between AC and DC. Right, okay. Isn't that interesting? So there are different ways of conducting electricity. DC is the type of current that we see in batteries, typically. AC is what we get from plug sockets that can travel distance. So if electricity needs to travel distance, it's AC, whereas batteries are DC. Very, very different. So the signs that we have in the BSL glossary is DC, direct current, AC, alternating current. Okay? the children had to come up with their own presentation. So they went home and came back to school to present about the difference between AC and DC. And we wanted to see how, because the word current has slightly different meanings. It can be electrical current, or of course it can be current as in time current or tense current. So we wanted to see what was going on with their use of sign language when they were talking about, and they did they did use the general sign. So you can see that it's very hard. You give kids the signs, you prepare them, this is a presentation, and yet still on the day they will use an out of context sign for current. Yeah, so we use this is alternating current, and DC is different. And obviously it will be very different in different countries, but the children were not using the conceptually accurate signs. So they do need access to these signs and the opportunity to practice. Looking at the very young children, the 5 or 6 year olds in the study, there was an experiment in terms of objects floating or not in water. So they were looking at density, and the teacher was asking the kids to find things in the classroom that they would throw into a tray of water and guess whether the object was dense enough to sink or not dense enough to float. So this was an experiment. So they would wrote down what they expected to happen with objects such as oranges, all sorts of different objects. Such as feathers, or all sorts of different objects. And we observed the students taking part in this experiment and finding out whether they were right or wrong. These are little 5 and 6 year old kids getting very excited about dropping things into water. But at the end of that, the teacher would then explain why certain objects would sink or not, and introduce the concept of density to the children. You can see it up here on the slide. This is our sign for our glossary project. So how tightly packed molecules are in an object. So in metal, they're very, very tightly packed. So it has a great deal of density and then a lot of weight or mass. And other objects don't and will float. And we were observing all of this thought, this is a really hard concept to explain to 5 or 6 year olds anyway. At the end of the lesson, the teacher would ask the students, why certain things would float or not. And these tiny kids actually used the sign back. And it struck us that these concepts are teachable with conceptually accurate signs. If you give these children the opportunity, the access to develop their understanding as a result of using these signs, we do see good results. This is another interesting example from our observations from our project. This is a video, so can we play this video? So that's the video, that's the sign for water cycle, which describes the process of rain, evaporating, going back into clouds, hitting mountains, and so on and so forth. Again, I was watching, making some observations in another class, and the teacher was asking, using a picture in a book that had the clouds and the river and the sea in it and so forth. I asked a little girl who was 8 years old what was going on, and she used this sign exactly the way that Gary uses it in this glossary, and it was a real moment, I mean, an 8-year-old, and the teacher said to the girl, well, I think you're wrong. So she made the sign again for water cycle, and she was told that that's not right. And the teacher used the signs for water and cycle, the regular signs that we have in BSL, almost relying on the English. And if we want to encourage children to really develop the concepts in their heads and the pictures to go along with these concepts, we obviously need to move away from that English-informed signing. So it's very important that we develop conceptually accurate signs to have dialogue with the kids to ensure their understanding. They can't do that by mapping signs onto the English language. And onto this question of mapping. How important is iconicity in coming up with these signs? I mean, it's always good when we see that a sign has some sort of relation to the object that it describes. Obviously, when we use the sign for house in BSL, I think everybody understands that I'm designing a pitched roof in order to mean a house. It represents and stands in for a house in British Sign Language, and we can see the iconic relationship between form and meaning. Now, a house meaning a house for a child is fine, and you can teach a small child that. I think we would mostly agree. But it could also be a tent or a mountain. It could be a number of different things, a plethora of things that have two sides at that angle. Okay, children still have to learn what the term relates to. So I'm talking about sailing, if I know what sailing is, but a child might not yet have experienced yachts before, been on a yacht, understood any of those things. So we do, I mean, iconicity is important, obviously, but there has been some research to show that the first 10 signs of life, which as we can expect would include mummy, daddy, me, those sorts of signs, they're not iconic. Not many of the first signs that people acquire naturally in sign languages are iconic. In fact, only 30% of initial signs actually have any iconic relationship with the concept. So this was back in 1984, so it's quite a while ago. But luckily, we've had some more recent research in 2017 that when we look at 4 to 5-year-olds rather than the tiny 3-year-olds, the iconicity does seem to support learning, but this needs to be explored in a great deal more depth. Iconicity surely is important in helping learning, but there's a great deal of debate as to how important, what the scale of that importance. Can we move on, please? So this year has been really special, perfect for us for having all these discussions, having all these groups. There's been a massive expansion of work and projects going on around the world, and now we all have a greater knowledge of what each other is doing. So we've covered the top 3 aspects of what we wanted to do in this year, but of course we have to limit ourselves in the project and ourselves in this presentation in terms of what we can cover. So we've got lots of work going on, but it's very piecemeal. It's not sustainable. We need to look at where funding is going to come from, where the gaps in sustainability are, and that's where this white paper comes in. It's very important to have a foundation to support all of our work with kids. If we're thinking in terms of growing what we're doing for future generations of children and working with the schools, we do need the evidence, we do need the funding in order to fund the research to put us on a positive cycle. So after this year of STEM is done, we need to think about what we will be doing. And we've got our activities focused in 4 main areas. We'll continue creating STEM signs, broadening out our work. And it shouldn't only just be white people that are doing that. We need to look at enhancing diversity in the science community whilst we're continuing to create these STEM signs, because, of course, technology moves apace and we need to keep up in our linguistic efforts. Also, we need to look at how we're going to improve the pedagogy or the teaching approach of STEM for deaf and hard of hearing students. Whilst at the same time, as Carrie was saying earlier on, we need to have these ongoing discussions about ethics and technology. Who's going to be involved? Who's going to be driving these projects? Because we don't know if we're going to be involved in years to come. How do we keep these projects sustainable? And with that, thank you very much. We've come to the end of our presentation. Thank you.